Hey class, Absolute 5 here, and today we're going to talk about factoring by grouping, part 2 of the first part. Because I know the first part we did the GCF, which is what you're going to need to start factoring these kinds of problems. Now, step 1, group the terms in two groups of two terms so that each group has a common factor. Second step says, step 2, factor out the GCF from each group. If there is a common binomial factor, step 3, factor it out. Step 4, if not, rearrange the term and try these steps again. All right. Wow, this is crazy. So we need to, so to factor by grouping, right? So what you're going to do is this. We're going to take two terms here. So when we take the two terms, we're going to try to factor it out. So let's say I'm going to take 15x to the third minus 10x, and I'm going to factor it by grouping like this. Let me see. Sorry, I just need to move up. Factor by grouping, just making sure. And then I add 6, I put parentheses 6x minus 4. Now we think of the common factor of each of these terms to factor out for the GCF. So for 15x to the third and 10x squared, the most I know I could pull out is an x squared for the x's, but for the numbers, I know I could pull out a 5. 5 times 3, so 3 will be what's left in the factoring. So also there's an x because it's x to the third. As for this, 5 times what will give me 10, 2. That's that GCF there. This GCF would just simply be 2. So it'll be 3x minus 2. Now, here's a good trick. You can factor out these two terms of these two terms there. So it's kind of like you're factoring out another factor. Or when you see the same factors, this is how the factor is going to be when you're done factoring. So meaning your answer would be 5x squared. Well, hold on. Let's write it as 3x minus 2 times 5x squared plus 2. So you see those terms you factor out are also going to be the terms you use to multiply. You could write it as, there's two ways to write this. It doesn't matter because it's commutative. So I could have written this as 2x squared plus 2 times 3x minus 2, or the other way around, 3x minus 2 times 5x squared plus 2. You still get the same answer no matter how you do it. So now let's do it again. Let's group like terms. How did I know what to group? It's a very good question. It's better to group terms that you know you can factor out. Like for example, I know the first one was easy because you could just pull out the 5 and the 6. The 2 for the 6 and the 4. This one's a little bit different. Now, intentionally, you want to first try to pull out the 4xy with the 3x squared because it's right there. But that's the thing. It's not the case. You need to reorder it so this way it makes more sense. So for example, we want to be able to factor out the terms we want to pull out. So for example, not only the variable, we also want to pull out the numerical coefficient. So I'm going to highlight these two. I'm going to group these two in this way. So it'll be 3x squared minus 3x plus 4xy minus 4. Now it makes sense to group these two terms. Because when I group these two terms, I can factor out much easier. So I'd get 3x as the GCF here. So I'm left with x minus 1. Plus, I can factor out a 4y in the next term. So I'm left with x minus 1. So you see the GCF is right there. So my answer will be 3x plus 4y times x minus 1 as my answer. Okay, that will be my answer. Moving on to the next term. Same idea. This one, you want to group like terms. So how do I know? Well, let's look at the common factors. We have 2's and 2's and 5's and 5's. So why not group it that way? Why not rewrite it as 2a squared plus 2a plus 5ab plus 5b. I group like terms. I'm going to factor out a 2a, I'm left with a plus 1, and for the middle term, I'm left with 5b, and I'm left with a plus 1. So therefore, my factors are going to be 2a plus 5b times a plus 1 as my final answer, okay? And here's the thing. You can check it by simply multiplying everything out, and you should get the exact same answer that you originally started off with. It's a really ugly arrow. I'm not even going to draw that. So this one looks similar. So let's rewrite this as, the thing is, this is not even rewritten as in descending order. Because if you notice, we have 3x to the third minus 2x. So there's not even a 2x squared, it's 2x minus 9x. So I say rewrite this in terms of the order of descending powers, or degrees in this case. So it'll be 3x to the third minus 9x squared minus 2x plus 6. These terms you can definitely factor out. So I'm left with 3x squared. I'm left with 3, oops, not 3, whoa, definitely not 3. X minus 3 is what I meant to write. And then for the middle term, minus, I can factor out a 2. So x plus 2. Oh, no. Wait. So wait. If we're going to group like terms. Wait a minute. Hold on. It would, no, I'm sorry. I'm bugging. Sorry, I'm bugging. I'm sorry, I'm bugging. So it's negative 2x. That's what we're grouping, right? So when we're grouping this, to factor out a term, if I factor out a negative 2 in the first term, I would have to factor out a negative 2 in the second term. So what I'm left with is be negative 3, because it makes sense. So 2 times x would be negative 2x. 2 times, sorry, let me say that again. Negative 2 times x will give me negative 2x here. And then negative 2 times negative 3 will be positive 6, so it has to be this way. And then I'm left with 3x squared minus 2 times x minus 3. And those are the factors right there. A little tricky. Even I got tripped up there. Same idea. We write this as 3xy minus 3x minus 2y plus 2. You group like terms, and I'm left with 3x times y minus 1. Then I factor out a negative 2. So therefore, what's left is negative 1, y negative 1, because we have to get back the same terms. So I'm left with 3x minus 2 times y minus 1. And that's my answer. Hopefully you're getting the rhythm of this thing at this point. Whoa, this is a messy one. All right, let's rewrite this as 4x to the third minus 20x squared plus x minus 5. Okay. So let's get our GCF together. 4 is definitely a GCF for the numbers. And as far as x, it would be x squared. So 4x squared would be just x, what's left. And inside would be minus 5 plus x minus 5. Can I factor anything out of x minus 5? Well, technically I could factor out one thing, and that is a 1. Because remember, x and negative 5, they don't have anything in common. Unlike our previous example where we had 2, we had negative 2, we had 5b, we had 4y, and so forth and so on. So why is this one as a GCF? You need to factor it out because it's necessary. Because now, let's say if I didn't put that 1 there, what would I put for this part? What would the 4x squared be? We wouldn't know. But that's why they say you have to have the GCF at least 1. So therefore, the GCF, the greatest common factor, would be plus 1 for the 4x squared times x minus 5. And you can check if you want. Let me see. All right, so I'll let you guys check if that's true for homework, and also this problem here, you try it for yourself for homework. And so leave your answers down in the comment section below. If you have any questions, leave your answers and questions down below. And that's the lesson for you guys. I hope you enjoyed it. Be sure to like, share, subscribe to my channel. Mash that bell button for more content, and I'll see you guys next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate.